Good morning to all the participants. For today's session, first session, we have an expert. Uh, uh, his name is Professor Surendra Singh Kachhwaha. He is the professor of mechanical department in the School of Technology, Pandit Dindayal Petroleum University. Uh, uh, he has a wide range of experience in the renewable energy sources, and during his professional career, he is affiliated with the number of professional institutes, even professional uh, bodies too. Okay, you can consider NIT, Kurukshetra, ISRO, Ahmedabad, and he was awarded a Bri Air Award in 2012. And Professor Kachhwaha, he is working as a chair professor at Suzlon since 2018. And in the research field, he has more than 50 publications in international journals and conferences. So, without wasting the time, I'm handing over the mic to the Professor Kachhwaha. Sir, now over to you.
Dr. Bharatbhai, before I start, can say the time is 2 hours, but can say, should I keep some time for regarding that question answer session is there?
Sure, sir.
Loa.
In what way I can proportionately, I can say, well, like I said, time given, you have given me the time from 10:30 to 12:30, right?
Yes.
So, how much time should I keep for question answers, roughly around?
Sir, after first session, after 12:30, we have a small break for 30 minutes for lunch. So if you wish to extend for 10 to 15 minutes, no matters.
Okay, so it means if I continue for 10:30 to 12:30, there is no issue.
No issue, no issue, sir.
Okay, okay, yeah, thank you, thank you. Yeah, so very good morning to all the viewers. And again, you see, on the online we are meeting, and really I would like to thank the organizers, Dr. Bharatbhai Khatri, and the HOD Mechanical, this Modasa Government Engineering College. And really, it's the right time that they have started sponsored the program Alternative Fuel from because alternative fuels related with the information, and this is virtual faculty development program sponsored by AICT Training and Learning Atal Academy, right? So this is a very good chance, and I hope that the viewers might have enjoyed the various views from the academics and plus industry people also. And it's right time that fuel point of view, there is a strong government of India policy is there, and in the near future there is a blend of fuel as well as battery. It will be the future in our country in next 1 decade. Now, remember that uh, when I have discussed with Dr. Bharat that what should be the topic, in that case, I have gone for this biodiesel production because last 10 years I am working in that area, and biodiesel is a typical substitute for diesel. And remember that in our country, we have main consumption in terms of you can say fossil fuel is the diesel and petrol. Diesel consumption is four to five times higher as compared to petrol. And plus, at the same time, we should remember that any price fluctuations, and recently you have noticed that a lot of petrol has gone 100 plus, diesel is 90 plus. The point is that anything change in petrol, of course, it will be a financial burden on a middle class, but economic point of view, or can say lower middle class, and the country's whole economy is concerned, the main issue is that slight variation in the prices of diesel means the all your price of vegetables, price of goods, and everything will rise. So, from my personal point of view, the substitute for diesel is a very, very important one, and biodiesel is one of the most important substitute uh, for diesel. From that point of view, I decided to work in the case of, can say, substitute for diesel, that is biodiesel. And country has a strong policy, and at present, even the less than 1% blending is there. But in the near future, the quantity of blending will increase. Whereas in the case of petrol, the blending is around say 2%. It is there, and ethanol is the blending for the case of petrol. So both the things are going parallel, and nowadays we are hearing a lot of things regarding the battery also. So in a combined way, the policy will move, and accordingly we can sustain or can fulfill the requirement of our country. Now, the main issue is that when we say that biodiesel production, there are challenges ahead. It's a question mark. Now, what kind of challenges? There may be certain challenges are also there, and plus technology challenges are there. In my lecture, I will focus on both kind of challenges. One is, can say the policy challenges as well as the technological challenges. Since most of the listeners are faculty members, I will tell you that how this conventional technology has become old and people are working in the new areas, and those new areas can play a very, very important role. Besides this, we have to be updated that once the new area is coming for biodiesel production, same technique can be used for wide range of different applications. So that we have to keep in mind that suppose we learn a particular technology, then we have to be aware that that technology can also be used for other applications also, and a huge range of applications are there. And particularly, I will focus more on PI techniques, that is the process intensification technique. Uh, My talk, I will start with the beginning of that. What are the different categories of the fuel? Main, what are the requirements? Then I will talk about the cavitation-based process intensification technique as compared to the conventional technique. And first, I will discuss about the process intensification technique for biodiesel production, and then I will talk about the then I will talk about this substitute for petrol, that is a bioethanol production that is there, right? And besides this one, since ours is an agriculture country, the biogas production is also important one, and in that case, how the cavitational technology can play important role to enhance the biodiesel production. There are very simple techniques either through repowering or with the integral part of the system, one can enhance the biodiesel production and its quality. Besides this one, a lot of people are working in the area of hydrogen. So through biodiesel route, one can go for hydrogen. And besides this one, there are many other, can say nowadays a lot of talk is going on regarding that how to increase the farmers' problem. That we have to, government is committed that how the farmers' income can be doubled. So in that case, this PI-based techniques, that is through which we can extract the oil, and how the crops can be used to extract the oil, that is also important one. And the technique used is a wide range of applications, and even your recycling of spent lithium ion batteries, this technique can also be applicable. So the point is that when we talk about certain technique, we have to be aware that how these techniques can be applicable for wide range of applications. And I'll just, in my lecture, I'll just prove that a couple of techniques which are very simple, not rocket science, but they can be applicable in a wide range of applications. And that we have to, even in our teaching, there should be the integral part, and teaching as well as the research work, project work, where students can learn these techniques and implement some innovative ideas. Uh, as I have told you that category wise, you can say uh, renewable fuels, biodiesel is a substitute for the case of diesel, and a huge amount of, can say quantity of diesel is consumed, and around at present one third of diesel is produced indigenously, and two third is imported from this Arabian countries, and Middle East. We are purchasing from Saudi Arabia, Iran, and even some of the portions are imported through Russia also. The point is that we have to be very careful that once we use a typical fuel, then dependency on other people should be as minimum as possible. So that point of view, the policy play a very important role. And in a similar way, bioethanol is a substitute for petrol. Now the issue is that bioethanol technology well established, but the main point is that if you convert all the sugar canes and the edible crop into the ethanol, then there is a problem. So there must be a balance in the policy that what fraction we can use it for ethanol production, and the remaining thing we have to keep it for edible purpose. So that as a combination and that fraction is important for. And remember that the third one is, can say, hydrogen fuel is there. So almost as compared to all fuels, hydrogen is considered the best one because after combustion only we can get heat and the water. But main issue is that still people are struggling to manufacture the hydrogen or to produce the hydrogen with the least cost technology. Technologies are available, but to compete with other technologies, that is the main issue. But I'm sure that people are working in that area, and in the near future, people can get the breakthrough in hydrogen. Even this hydrogen, this PI technique can play an important role to enhance the hydrogen production. Of course, biogas is since our is the agriculture country, so biogas is a very important one, and all agriculture purpose. This biogas enhancement means the quantity of biogas as well as quality. Quality means it is a main constituents are CO plus CH4, the methane. How the percentage of methane can be increased? In that case, we can say that quality of bioethanol is a good one. And battery, again, everybody is talking about the battery as a substitute for the case of fuel, liquid fuel. But remember that it will be long way. End of this decade, there may be, you can say, battery will be able to substitute the fuel. But battery wise, you can say, in cities, the electrical vehicles are the good one. And outside the city on highway, etc., one can go for the liquid fuels. And one of the professors from IAC Bangalore, they have proved that he has compared this can say life cycle costing of this internal combustion engine and life cycle costing of electrical vehicles. So then almost can say this they both are same, but some upper edge regarding this internal combustion engine, because he says that some fraction wise life cycle costing is lower for the case of this internal combustion engine as compared to the electrical vehicles. So that's very interesting. Now, main issue is that sustainable fuel requirement is a must for all kind of fuels, right? And they must be, because every year proper fuel must be generated. And at present, remember that Indian scientist has played a very important role regarding the production of crops and other things. Excellent. But the point is that in terms of energy farming, still a lot of work to be done, and there is no scientifically, you can say, uh, efforts has been done for energy farming. At present, if you just see the sources, what are the different sources, then main is that in our country, that if you just divide that oil sources, then there are edibles and non-edible. Vegetable oils, in that case, it is cotton, groundnut, uh, date, wheat, coconut, seed, all kinds of oils are available. But remember that they are edible oils. And edible oil means we don't want to create a scarcity of edible oils if you just convert into biodiesel. So we have to be very, very careful that which one we have to use and which do not use. So government policy never encourage the use of edible oils for production of biodiesel. Then what is the option left? Fortunately, in our country, unlike you see European countries, edible oil is in excess. So they will go for converting the excess edible oil into biodiesel. But in our country, this is not the scenario. In our country, the point is that there is a scarcity of vegetable oils. That's why the prices of vegetable oils are going high. So what is the option left us? Option left is us is that non-edible oils. Fortunately, we have more than 500 species in the country which are non-edible in nature, and they can be converted into biodiesel. Fundamentally, any kind of oil or fat can be converted into biodiesel. So our approach is that in our country, this non-edible oils species are there. So all these species written here, Jatropha is one of the major well-known, and another important one is the castor one. In Gujarat, if you know that castor production in Gujarat is not only highest in the country, in our country, it is the highest in the Asia, and lot of castor seeds are exported from our country to other countries. So we have to see that how the castor can play an important role in production of biodiesel, and then that can be further blended with the diesel. So we are working in the last couple of years in the case of castor oil, and we are mixing it with some other oils. And just by mixing the oils, I will show you that properties are improved. The main focus is this one, non-edible oils. We have the main focus. Besides this one, animal fats in our country, due to the nature of the religion, other things, people do not use it. But in foreign countries, they convert the animal fat into the biodiesel. Another category under others is that main thing is that this waste cooking oil, this cooking oil, once it is wasted through restaurants and other things, then we can use this waste cooking oil for biodiesel production. A huge amount of waste cooking oil is available, and at present it is just sometimes it is thrown away, sometimes it is collected, sometimes it is mixed with the lubricating oil. So a lot of can say illegal things are going on regarding this waste cooking oil. So this cooking oil, waste cooking oil, if it is collected properly, then it will play a very important role to convert waste cooking oil into biodiesel, and it can be used as a substitute for biodiesel. Now, before I come to algae, bacteria, microalgae, and other things, the issue is that you see that this chart is for the case of, let's say, biodiesel, right? These are the main sources for biodiesel. In case of bioethanol, there are different generations. Of course, generations are also applicable for the case of this biodiesel also. The first generation biodiesel, normally biodiesel as well as bioethanol, this food biomass is used, and that the different processes, harvesting, milling and grinding, clarification, evaporation, these are the different processes followed. But the main issue is that it is a food biomass, so we cannot use it. So nowadays, almost as a policy doesn't permit us, or otherwise you have to take a permission. In second generation, what happens? The non-food biomass, this which is suitable for our country, and people have all the same steps are involved, and then after a lot of number of steps, fermentation, distillation, we can get a bioethanol. So knowledge is not a rocket science. Knowledge is available 10 years back. Still, I can say the plants are there as conventional technology, and they are converting to the bioethanol. Only that policy-wise, the point is that how much fraction we can convert it into this bioethanol. That's the more important one. Of course, third generation, the new sources are there. The algae, it is there, and through harvesting, extraction, and then biomass, we can have fermentation, and then distillation, we can get the bioethanol, right? And then the fourth generation is still at a developing stage, where we can modify genetically this algae, and then this algae, once it is genetically modified, means the oil content can be increased, and this can be used. Even people say that algae can be solution for both the case of food as well as fuel. Whatever the protein elements are there, they can be used for the medicines and the food, whereas the oil content, lipid content, that can be used for the case of this bioethanol and other things. So these are the different generations, and we can say that non-edible oil generation is the second generation oil. And at present, maximum either biodiesel or bioethanol, both are produced through this second generation fuels, which are non-food biomass or non-edible oils. They are used. So this is a rough scenario about that one. And remember that not even a single source is sufficient to fulfill the entire requirement. So therefore, is that the technology, once we develop the technology should not be specific to a particular fuel, a particular feedstock, or a particular fuel. Feedstocks can vary, but technology, we cannot change it, because once the plant is installed, then we cannot say that is a feedstock specific technology. So technology must be independent of the feedstock, so that we can convert the raw oil into the biodiesel. And this, in a similar way, the same is true for the case of bioethanol, where the raw stock may be different depending upon the generations, and then we can convert the raw feedstock into the bioethanol. So this is a brief idea regarding the different types of fuels, feedstock used in the case of biodiesel, and the different type of feedstock used to get the final product of bioethanol. Okay. After once this fuel and other things are there, then we have to go for this. What should we call it as engineer? It is our responsibility that whatever the techniques when we use, so we always try to classify first, and then we go for the different details and other things. So here, a simple classification of techniques are available. And before I go for the classification, I have not included a diagram of the conventional technology. Conventional technology is simply this mechanical stirring technology, where a stirrer is there, a drum is there, and oil plus alcohol is mixed with catalyst, and continuous RPM, 100 RPM, 200 RPM, the shaft will rotate. And I have a class. Yeah, the point is that uh, in that case, uh, conventional mechanical stirring will not use it. It requires a lot of drawback. In hours and hours, reaction time is there, energy consumption is higher, catalyst requirement is higher, and plus other lot of this can say, post post biodiesel production. Can say the drawbacks are there. So considering so much drawbacks, and among them the most important one is the time consuming, requires high pressures, requires reflux conditions. All these things are there, right? So due to that one, people are struggling that Why not the new technology should be used where the reaction instead of hours it can be converted into minutes. Catalyst requirement should be less, and at the same time there must be heterogeneous catalyst so that it can be reused continuously. And alcohol and other things also, normally you can say methyl alcohol is used, that is also a part of you can say this non-renewable oil. The issue is that how these things can be substituted and technology can be go in a very fast way. The recent technology point of view, the to challenge this, because to replace this conventional mechanical stirring techniques, people have gone for this typical surface tension driven cavitation classification or cavitation based techniques. In cavitation based techniques, there are two types of, you can say, challenges are there. One is sonication, means based upon the sound frequency, or I can say sound waves, or that is also called as ultrasound waves. And another is the hydrodynamic, in which the pressure variation, due to pressure variation, there are velocity variation, and due to velocity variation, there is a fluctuations and turbulences are created and bubbles are formed. So in both the cases, bubble formation is a very important one, and at micron level, the bubbles are formed and they are grown, and then finally collapse of the bubbles takes place. Or normally the term used for collapse is the imploding of the bubbles. So classification point of view, it is sonication and it is hydrodynamic. Now remember that in our can say teaching community or research community, we have typically two categories of can say persons. One is belongs to the science stream, another belongs to the engineering stream. Normally, science stream they people work on the case of sonicators, and just at a small scale laboratory they do it. That is also important. Initially, you can say beginning through sonication is a very important one, and at least you can get an idea that at laboratory level what should be the conditions for transcription or biodiesel production. But industry want not a small one. They want the scaling of whatever you do in the laboratory. Scaling point of view, this hydrodynamic techniques is a very important one. You can scale it in a big way. But before scaling, you have to go for sonication technology. So engineers work in the case of hydrodynamics, in which you can say hydrodynamic cavitation techniques are there, where a big size, can say this industrially point of view, you can say scale, big size scaling plant can be used. But for that one, the sonication data is important. So what I want to say that uh, scientific work done by the scientist or science people is a very important input for engineering applications, right? So both engineers as well as scientists from science discipline, they must coordinate each other, and in that case, there will be a win-win position, right? In this, let me talk first about this sonication techniques. That how this technique is a very important one for biodiesel production, and the same technique can also be used for nowadays. They are also using for bioethanol production also. Now, mechanism point of view, the point is that this particular, you can say, sonication is a result of pressure variation in a liquid when ultrasound waves passes through. Ultrasound, remember that it is a huge number of applications in the industry. Here, a typical horn of ultrasound is there, and here we can have a mixture of oil, that is non-edible oil, plus alcohol, methyl alcohol, plus catalyst is there. And in this mixture, what happens? We can dip this horn, right? And then this is the typical, let's say this, the actuators are there. This actuator is connected with the generator switchboard, and then once the electricity is there, then due to vibration will take place, and due to the vibration, horn generates some uh, ultrasound or sound frequency inside the liquid. And due to this sound frequency, what happens? Just look at the mechanism. It's a very important mechanism where there's a generation of cavitation bubbles with water vapor. Inside, what happens? There are certain gases that are trapped. Maybe you can say air bubbles may be also possible. So these bubbles are trapped, and due to this, can say this vibration of sound vibrations, these bubbles, can say the detachment of air takes place inside that one. Once the bubble is formed, it will pass through a cyclic. C is for compression, right? R is for rarefication, means expansion. So continuous CR cycle it will go when there is a R is there. The point is that it is volume is increasing. C is there, its volume is decreasing. So continuous increase, decrease, increase, decrease. It will go there, and finally, once the can say this instability comes, it will just implode. And at the time of implode, what happens? Its temperature is around 5,000 degree Kelvin. You may surprise that how it is possible that 5,000 degree Kelvin is possible. This is at micron level, right? And the pressure is said that bubbles, maybe you can say they will just sign once they are imploded. The pressure is 1,000 atmospheric, or in terms of gigapascal, you can write. So issue is that these bubbles with high temperature pressure, the entire system is at you can say it is atmospheric conditions. But at micron level, what are this particular condition of high temperature pressure is that it is at micron level it is there, right? So these things we have to very understand very carefully, and this quantity of can say once this temperature pressure is there, so remember that at 500 degrees centigrade the dissociation will take place. So that's why at this temperature at micron level, hydrogen plus, OH minus, and many radicals and redox can say components are there. And those components play a very important role in mass transfer rate and mixing of the fluid itself. Right? So this is can say this ultrasound mechanism. Even recently, people have can say earlier people are knowing, but mathematically, a lot of number of models are there. And one of the famous model given by Rayleigh, it is used for to analyze this bubble formation and other things. Now, ultrasound, you see how you can apply the ultrasound by means of this probe. That is that is a horn type of probe. In that case, what happens? What are the frequency it is there? Directly, because these frequencies can create bubbles inside the liquids. It is more efficient, right? But the point is that mass transfer rate is good, but the heat transfer rate is not enough. So, and for entire surface, if you use a big size liquid, in that case, it will be difficult, right? So in that case, people use a bath type of sonicators, where at the bottom the actuators are there, and for a wide range of surfaces, the frequency can be added. Normally, you can say in this case, the high intensity focused ultrasound is considered the most advanced one. That it is all a game of frequency, amplitude, and your power consumed. Now, this entire acoustic cavitation which takes place, right? It is nothing but different to nucleation. Nucleation means the bubble formation, then growth of the bubble, and finally collapse of the bubble. This continuous cycling process is such a way that finally it collapse of the bubble under acoustic waves. So normally, what happens? High power ultrasound is introduced into a liquid medium, causing the sound waves to transmit in the fluid and create alternative high pressure. Right? So compression, verification, continuous high pressure temperature that takes place inside that one, and due to that one, what happens? Once the explosion takes place, in that case, what happens? The mass transfer rate will be very high, and plus at the same time, the reaction will be very, very fast. Just a minute. Now, when we talked about this ultrasound, if you just search in the literature, a very simple technique and at the same time wide range of applications. So we should be aware of that. What are the due to which features this ultrasound has created a lot of buzz inside the industry for application of that one. Mainly, you can say that people from the industry say that ultrasound is very small, and for small batch production, one can use it. But for very large productions, it is not used. I will just tell you that what are the remedies. It has come in the market recently, so that it can be big size ultrasound can also be used. But before that one, I'll just mention here that main thing in the case of ultrasound features are that the time requirement is very small. Whatever it is done in the case of mechanical stitching in hours, here it can be done in the case of minutes. So due to that reason, main reason is that micromolecule mixing takes place and caused by the acoustic radiation, and hotspots are generated and they creates the time and energy saving, right? Besides this one, yield is very high and selectivity increases. The physical and chemical transformation are altered because of the cavitation phenomena. And this phenomena causes efficient agitation, dissolution, mass and heat transfer rates, and reagents sonolysis. Right. Due to that, what happens? This whole high yield, what happens? The selectivity, how it increases? The chemoselectivity increases, the regioselectivity increases, and stereoselectivity is enhanced. So therefore, once all kind of stress, consider this selectivity increases, the overall selectivity will also increase. And the main reason that why there is a high reaction rates are there, the reason is that you can say once this you can say the jet formed and implosion of the bubbles takes place, then the point is that because remember the temperature at micron level, the temperature is 5,000 Kelvin, and at 5,000 Kelvin the dissociation of liquid will take place. So it is, you can say, H dot, OH dot, H2O, sorry, HO2. All these are considered to be the radicals inside the liquid. And these radicals just act as a substitute to uh, catalyst. And therefore, due to this reason, what happens? The requirement of catalyst is reduced. Besides this, the turbulence created due to the propagation of alternative pressure waves enhances the mass transfer rate. So the main thing is that how to transfer the mass transfer rate, depending upon that one, the reaction rate will depend. The thickness, the thickness of the liquid film is reduced, thus the gas transfer is enhanced, and the bubble coalescence is reduced. Thereby, the interfacial area of the gas transfer is increased. So high reaction rate is one of the most important features. Besides this one, high extraction yield through the seeds, how much fraction of the oil you can remove. This is very important. At present, you can say just by compression. This compression of can say compression machine is used, and we can remove the heat, but remove the oil. But this will require 50% of the uh, oil removal for the seed has gone to the manufacturers who follow this one. Of course, we are discussing about the high extraction heat, how much fraction of the heat one can remove. Remember that in the case of castor, uh, 50 gram seeds you can get it around 42 to 44 gram of oil. Sorry, 100 gram of oil seeds are there. Then the 42% you can get it from the oil itself. And remember that there are certain properties are there, variation takes place in temperatures. In that case, what happens? This is better morphological properties are available. And in that case, the crystallization will not take place. And once the crystallization doesn't take place, the point is that whatever the reaction takes place, this will remain the faster. Amorphicity, again, it is a cooling rate. Cooling rate means it doesn't let the product crystallize, which is beneficial, or sometimes amorphous projects. Amorphous means which are not crystal, they are active than their corresponding crystalline counterparts. These are the advantages, but besides this one, there are certain uncomfortable bubble coils are there, which can cause undesirable effect also. So bubble formation and other things should be governed properly. Now, further ultrasound, how we can enhance it? For that one, we can have a hybrid reactor, where ultrasound from the bottom we can give it, and at the same time, the microwave we can give from the side. In that case, you see two fields for microwave, electrical and magnetic field, and this ultrasound field is there. All the three fields, you can say they will act on the liquid one, right? So due to that one, what will happen? The heat and mass transfer rate will be increased. 1 minute. हाँ 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 मैं करता हूँ सर मतलब जी so my point is that here certain drawbacks are there. If the bubbles are not controlled, in that case they will create a problem. The whole thing is that ultrasound is a very you can say uh, well established technique, but application inside the industry is still, you can say, they are using for other applications, but for energy applications and for waste treatment and other things, still there is a lot of problems have to solve it, but they have the capability to do that one. So how to go for okay, say this scaling purpose, that I will talk later on. But the point is that the performance of ultrasound is very good for fuel production, particularly biodiesel. People have now recently tried for the case of bioethanol also. And besides this one, there are many other applications out there. Okay. Just you can see that we can further enhance it by mixing of that one. At the bottom, we can have ultrasound, and from the side, we can have this microwave. In that case, what happens in microwave? There are two fields. One is electrical, and one is your magnetic fields. So two fields from left hand side, which are perpendicular to each other. Bottom, it is a ultrasound field is there. When the three field act on the liquid mixture, the point is that in a very fast way, because there is agitation inside the molecules are there, and due to that one, the reaction will be very, very fast. That we have observed. But what is the challenge? The challenge is that you see, this particular vessel I cannot keep as a metallic or other portions. Why? Because this is a microwave. So my point is that we have to design this machine in such a way that in a big size, where big size sample we can use it and we can convert it into biodiesel or other applications. This is an imported Chinese machine. As a individual, this ultrasound is available in 1 lakh or 2 lakhs, right? As a microwave individually available at with 2 lakhs, you can purchase a very good microwave machines. But since we have these two things have to be applied simultaneously, so this we have purchased from China around say 12 lakhs, 13 lakhs we have purchased. But it is not a rocket science. Even if you produce this kind of systems, combined systems, that will be a great asset for Indian industry as well as you can say development of this particular fuel. At the bottom, you see simple bubbles are there, acoustic cavitation bubbles are there, and these are the typical chains are there. In that chains, the bioactive nutrients are there. When the bubble comes to this chain and it become bigger one, finally it expands. And when it expands, then it breaks the cell, right? And in that case, what happens? All these bioactive nutrients are there. They come outside and it is collected. So this is also applicable for all kind of you can say this algae or from the seeds, the food extraction, other things, whatever it is applicable, one can use that. One, this was ultrasound. Now people say that ultrasound, the main issue is that big size means a huge amount of petroleum you have to produce, right? That's why biodiesel you have to produce. In that case, from industry point of view, this hydrodynamic cavitation technology is a very, very important one. And it is very simple way one can construct. So I'll just first explain this diagram and then its feature that how we can use it. I have this particular chamber where I can fulfill that the oil plus alcohol in a proportionate way. Heater arrangements are also there. And for initial mixing purpose, I can use this impeller it is there. But otherwise, there is no role of impeller. Now, through this pump, right? It may be a gear pump or any kind of peritatic pump. So through that pump, this mixture will enter through this pipe, and then it is, I can say, ejected inside this particular cylinder, right? And through the cylinder surface, the oil stick and comes to downward. And bigger size droplets can go straight also, right? So the main issue in this case is that at the top portion we are having the nozzle. Point is that across the upstream side nozzle, there may be pressure of 2 to 3 bar or sometimes 4 to 5 bars. And outside the nozzle, there is atmospheric conditions are there, right? So by this pressure difference, what happens? Inside the nozzle, one can create cavitation techniques. So cavitation is nothing but you can say micro level droplets are there, and the pressure is can say converted in such a way that due to high turbulence will be generated, and at the same time, you can say these particles once the collapse takes place, they will can say they will implode and reaction will be very very fast. Now, in this system, you see this is a drum, pump is there, and through that nozzle we can spray it. So continuous supply and continuous rotation of this project is there. We can do it, and in a almost we can say that whatever we are able to do in case of this mechanical string. In the industry, it takes 2 to 3 hours for mixing and other things. Whereas in the hydraulic cavitation, 20 to 30 minutes one can do it, and one can mix very fast, and your solution will be much more important. This is a simple one. Just you can say a main component is a drum, storage tank, reaction tank. We can call it a reactor. Then it is a pump, and through this particular pipeline, we can throw it away from the this nozzle, and through boundary this droplet conditions as well as the surface area of this one is increasing. So in mixed mode, this cavitation based technology can be used for biodiesel production. Now here I would just like to point out that this uh, here you see, here we use the nozzle, right? Besides nozzle, in between there are devices can also be used. The devices, maybe you can say this venturi, this rectangular venturi, it is there. This can be central venturi, or there may be droplets. All kind of people have tried with all kind of, you can say, this cavitating devices, and simplicity point of view, this orifice is a good one. Why? Because easily you can get that in the market. So this is a typical diagram which I have shown for the case of 10-liter capacity I have shown, right? And now what happens actually inside the nozzle, or it may be even if it is venturi, say for example, if it is a venturi, it is there, venturi or orifice is there. Upstream side the pressure is high, downstream side the pressure is low. So it will go like this pressure, and inside the nozzle it will go decrease, and then it is a recovery of pressure recovery is there. Right? This kind of techniques is called as this cavitation techniques based upon hydrodynamic cavitation. Just a minute. HC is pure a mechanical device. You see, wide range of applications are there. Even in petroleum, also it is used. And we have to generate the hydrodynamic cavitation. For example, say this is device. And these are typical holes are there where, due to pressure difference, the can say this liquid comes with a very fast velocity, because as per the Bernoulli's equation, upstream side pressure can be converted into velocity. And due to these velocities, inside the velocities, the droplets are produced which are at micron level. And those droplets, once they implode, then they send it as a shock wave, and then what happens? The mixing and the mass transfer rate will be enhanced. Okay. So main issue is that Bernoulli's effect allows the fluid in the chemical reactor to achieve vapor pressure as it accelerates through these constrictions. Constrictions means this particular, you can say, venturi or orifice, creating a local boiling point, because due to, you see, what happens at local boiling point, effect effect which adds in agitating the mixture as a whole, often known as the hydrodynamic cavitation. In the case of hydraulic cavitation, the same mechanism as compared to the ultrasound, and that mechanism means formation of the droplets, growth of droplets, and implosion of cavity bubbles. Cavity bubbles or droplets, one and the same thing. And objective is to achieve high intensity or micro emulsion and high level of micro mixing in multi-phase. Normally, you can say this mechanism of hydronic cavitation is still not very known, as currently poorly understood, and it is moving in a fast-moving fluids whose dynamics response is a complex one. So models are available, but they are still approximate models for analysis of cavitation conditions. So main issue is that a controlled cavitation has wide range of industrial applications, and it is considered to be breakthrough the technology. So that's a very, very important one. And using this technology, easily you can convert to your any startup or etc. You can hold it. Now, a very important technique which I want to discuss is that rotor stator uh, reactor, or normally also called as RSR, means rotor stator reactor, and another is, you can say, it is shock wave power reactor, SPR, or some people call it as hydrosonic reactor. There are different names. This term is, can say, this particular methodology is called. Now, this technique has been kept by the industry in a very classified manner, and finally it has come out in 2000. Very scarce references are available for this technique. Hardly 10 to 10 people are there. They use this power reactors in the case of water to remove the impurities from the water. They can use that. Here, what happens? There are, you see, T1 and T2. Different tanks are there, right? So suppose the heated oil is there, and this heated oil can be collected here, and alcohol may be there. And here, the measured amount of this oil and alcohol, it is mixed inside this particular portion. Now try to visualize this portion. This is a very, very important techniques and very easily constructed everywhere without any sophisticated techniques. Any workshop is sufficient enough to construct this one. Now, here, look at this. You can say this whole assembly outside is called as the stator, right? Outside portion. Inside portion is a rotor one. Rotor can be here, it can diameter of 60 or further reduced. This rotor is there, and the different shapes are given for this rotor, right? So rotor information is available. Maybe you can say this plus you can see this is one of the important parameters. So we'll use this as a you can say 3000 rpm, 4000 rpm, 6000 rpm, a typical from can say from mean value to how it can be reduced, how it can be reduced and increased, and the information must be available regarding this change in rpm. Now, as this rotates, right? When it rotates, the point is that on the surface, what happens due to shear action and due to fast moving of the surface related to the fluid, what happens? The cavitation conditions are generated. And what are the cavitation conditions? Nucleation, growth of the bubble, and implode of the bubbles. So you can see that here, you can see this particular schematic. This is connected with the prime mover, which is having a different RPM, and we have here the mixture is inside portion. The mixture is filled and it is converted into there's a biodiesel or any other applications. If you just look at the whole, the shape is given like this, right? 1 centimeter into di already is given in the paper itself. So here the point is that you see, even if you want to produce a biodiesel, even there is an interdisciplinary approach you have to see. Now this is a typical cylinder, solid cylinder, but in a judicious way you have to do the holes. Holes are blind holes where you can do it. So for this one, what happens? Number of drums, hardly you can use one, two, or three. But the point is that if you get some, like I say, information regarding the patenting and other things, so you can just remove the options, couple of options you can reduce, and you can utilize it for even many applications, right? So these are the machines at which they are manufacturing this. They are manufacturing these rotostator things. You see here it is a typical assembly reactor is there. At this bottom, you can say inside this one is this pressurized shockwave power reactors, and outside you can see they are clamped. Okay, and here this portion is nothing but you can say this is nothing but you can say this portion, right? So here in this typical research, what happens? Many people, many supervisors can work. For example, one person can talk about the design of this design of this particular element, right? So normally this is less than 5 years, sorry, 5 rupees. It is a total cost, 5 rupees or 10 rupees, right? So my point is that this techniques can be used for this particular applications. That's very important and quick answers one can get it. These rotary starter reactors are suitable for large number of industries applications due to wide range of cavitation techniques. And what are the cavitation techniques? They are inexpensive and easy scalability. So this particular, you can say, this thing not only can be used for biodiesel production, but this can also be used for emulsification, reduce the FA content, homogenizing, dissolution, dispersion, and grinding process. Uh, you see, in that case, what happens? The chemical reactions and cell disruption due to high shear stress, mixing energy, elongation, stress, and turbulence. All factors, more or less, small or big, they act or they enhances the system into work output. Okay, that is the typical beauty of this shockwave reactors, where you can say if you can have inlet and one outlet, in that case you can make this system as a and energy. What is that? Renewable energy independent. It will not depend on the sun. It will not depend on earth. It is combined way. It will give you better results as compared to these two. Of course, safe and other things you can see. So you see, this whole research requires chemical engineers. This research requires mechanical engineers. This research requires this design of these drums. These drums are produced only by, I can say, this electronics people, electrical people. Then we can use it for application purpose. This technique is the most important one and gives a very good result. Just a minute. You see, mechanical engineers, what they have done in the beginning, most of our country, even in IITs and other things, faculty and researchers, they are busy in how to avoid the cavities. So therefore, you can see that very in-depth mathematical papers are there where if there is any cavitation zone inside the pump or a turbine, that should be avoided, right? But due to controlled cavitation, the applications has increased like anything. So mechanical point of view, only the one side of the coin that okay, we can avoid the cavitation. But other side of the coin is that huge number of applications are there. So nowadays, in last 2 years, lot of you can say the emphasis is given on cavitation technologies. Here you can see that there are two views are there. This is a typical rotor is there. Where side there are you can say that, these are the typical we can call it as cavities, blind cavities are there, and through this cover it is closed, right? Now the point is that when it rotates, what happens? Cavitation conditions are generated and mixing takes place very fast. Here, this particular you can say this reactor is connected with the shaft itself, right? In that case, one can find out very easily that how much is how much time it will take, how much reaction, how much condition is required, and any other thing is required. You can talk about that. Okay. So this is a typical example of 2.2 kilowatt electric heater is there, and which is connected via central access to stainless steel plate. So this is almost 2016-17 people are using. You can enhance it, you can increase this size, you can decrease this size. Based upon that one, you can develop the procedure. So almost all the things I have covered in this particular diagram. The cooling of the reactor, you can say it is done by the outside tube flow, and normally you can say water ethynyl glycol mixture was circulated. Normally instead of water, this for cooling purpose, ethynyl glycol mixture is can say distributed. Why? Because the viscosity become low, and at the same time, its boiling point is also changed. From that point of view, mixing is an important one. Sorry. Now, you see, I have in the beginning I have talked to you that regarding that mechanical steering, a lot of problems are there. Time consumption is there, and your energy consumption is also high because the operation is done continuously more than 2 hours, 3 hours it is there. Recently, the two groups, independent groups, one is from Thailand and another is from Korea, they have produced that okay by one group, can say it is Kamjam in 2021. They have produced this thermodynamic, or can say this particular, can say it is hand blender is there, and hand blender means the main feature of this hand blender is that it revolves around 10,000 rpm. Once it revolves around 10,000 rpm, then the point is that I can say the mixing will become very, very fast. That is the main advantage of this particular blender. And whatever the product is found, it can be just, I can say, removed from this force. Another important experiment was done by, can say, this Thailand group, where at the bottom portion, the can say the knives are there, or can say this cutters are there, and they will cut the water. And due to that, what happens? A huge amount of electricity can be saved, and that will be saved, and that will not be consumed for other applications. Here, in that case, what happens is the bottom, the mechanism is there. Here it is, the bottom is at the top, and this is that there. So now the point is that these two techniques for a small scale, one can use it, and you can optimize these two techniques. And then based upon the data of these two techniques, you can switch over to hydraulic cavitation. That is the way one should follow the path for in the case of fuel. Normally, as I have told you that it is 700 watt and RPM is 10,640 RPM is there, and high power you can say 200 watt and RPM is 10,000 RPM, and household this particular person Wong Sang Wang is in 2018 he want to say something, and it can be very easily used for application purpose, right? Now the main issue is that these two things, how we can apply it for, you can say these two things we can apply it for scaling purpose in a judicious way. Now, if these examples are successful, then the point is that we have to require a bigger size, the generators and other things. And if they are bigger, then quickly in terms of minutes, the mixing will take place very fast. Otherwise, you can say at laboratory level they are successful and no rocket science is required. So therefore, even the conventional mechanical steel can be substituted by high RPM revolution motors inside the mechanical steel. So in that case, they may be comparable with ultrasound and hydrodynamic cavities. So here, the main feature of these experiments are that they are less time consuming and effective biological processing techniques, and the percentage of 95%, you can say, the kind of theme one can achieve. The commercial, because any commercial technique, the 95% or more than that. That's why if you achieve that one, then that technique is considered a good one. Then high yield efficiency is there. And another important point is that why, because as compared to low RPM, why the mixing here is fast? The reason is that there is a synergistic effect derived from the very high rotational speed of the blender plates, right? Integrated with micro mixing level from cavitation phenomena, heat and mass transfer get greatly enhanced. Even in that case, the cavitation conditions are generated and the reaction becomes very, very fast. This was, you can say, even you can say small scale high speed reactors are considered, they are still in the race. And even at home, what we prepare for food, the same mixer with a very high RPM blender, we can achieve that fuel preparation also. Now, couple of things which I have explained. Now, there may be, you can say, certain challenges. We can call it as you can say this policy point of view, whether they are supportive or not. That is also important. Uh, we have the conventional policy that okay, whatever it is used for the edible oil purpose, so we can use it for, I can say, in that it is used for eating purpose. We cannot use it for fuel purpose. That was the conventional policies. But recently, I can say 2 years back, there is a drastic change in the government policy, and this is available on the website. That national policy on biofuels by Ministry of Petroleum and Natural Gas, they have announced that one. In that case, what happens? Production of ethanol from damaged food waste like wheat, broken rice, or any other food which is unfit for human consumption. If these two category of the foods are there, food waste are there, then these food waste can be used for ethanol production, right? So policy also allows conversion of surplus quantity. If you have surplus food waste, then one can do it. And a couple of states there is surplus food waste are also there. So instead of wasting them, we can utilize those food waste for bioethanol production, right? So that is a typical drastically changes in the case of, you can say, biomethanol. It is there. Now the point is that by mixing of this almost, you can say, up to 2017-18, a little bit old data, 150.5 crore liters of ethanol has been blended. And due to this blending, what happens? How much foreign exchange we have saved? More than 5,000 crores of foreign exchange we have saved. And due to addition of this one, what happens? The carbon emission is also reduced, and it is around roughly around 30 lakh tons carbon emission we have reduced. So there are two things. One is that we have found the substitute of that one, and at the same time, the cost would be low, and at the same time, CO2 emissions should be reduced. From that point of view, that's a very important one, and methanol play a very important role. This was a brief idea regarding the policies related to ethanol. But the main issue is that if the industry pays money to the for ethanol production, then the point is that there will not be any sugar available in the market, because what will happen? Industry always pay better money as compared to the edible things. So there is a typical balance balance should be managed while using for energy purpose and while using the as a input as a for food purpose. Now, the earlier slide was for the case of bioethanol. Now, this slide is for the case of, you can say, it is for the biodiesel, right? So if you say that blending of ethanol in petrol The target is 20% in which 20% and 5% blending, can say 20% up to 2030, we should have a 20% this bioethanol. And up to 2030, we should have 5% blending of biodiesel, right? At present, biodiesel blending is only around say 0.12%, and bioethanol blending is around say less than 2%. So from that point of view, policies are there, but the speed of blending is also not matching with that one. The reason is that in the case of can say biodiesel, the seeds are not available everywhere. You can say different. We have the climates and different way. So in that case, it requires a lot of proper can say planning, or agricultural scientist has to grow the seeds so that in a sustainable manner we can produce the biodiesel. Otherwise, there will be issue. And the same is in the case of ethanol, where the policy point of view, this bagasse and biomass, we can produce it, but at the same time, edible oils, this edible requirement should not be reduced. Okay. Now, this oil marketing companies are there, and they are just blending up to 10% ethanol in Andaman Nicobar. It is 10%. All other places, it is less than 10%. Okay. And why the blending is required? Because the CO2 emission is reduced. And at present, we are following the BS standard, BS6. We have directly jumped from BS4 to BS6. It has started in April 1, 2020 in the city of Delhi. And Delhi, it started in 2018, but in our country, other parts of the country, it started with this one. So to achieve the pollution targets or less emission of the CO2, so blending is a very, very important one. As far as the biodiesel is concerned, we require, and to achieve the target, how much biodiesel is required? So we are consuming around say 850 crore liters of diesel consumes every month in the country. And if you have a 5% blending by 2030, in that case, we will require 500 crores of liters of biodiesel required in the year. If this is the requirement per year in 2030, how will we fulfill it? So let us see the data. We have the almost, you can say, we are consuming 2,700 crores liter of cooking oil. We are consuming, and out of that one, 140 crores, can say this waste cooking oil or unused cooking oil can be collected from unused. Also, waste is a part of the waste from bulk consumers such as hotels, restaurants, and canteens. Remember that five-star hotels and canteens and other things. What happens if you fry a particular dish, then you cannot fry it twice. Otherwise, what will happen? It's the long chain will increase, and that liquid or that oil is not suitable for the case of eating purpose, because the FFA content and everything is different. So 500 crores of biodiesel is required, and this we can get it through 2,700 liters of cooking oil is there, and 140 crores are unused. We can consume from the we can just collect for restaurants, canteens, and McDonald's and different restaurants. And from this 140 liter, 110 crore liters of biodiesel can be produced, right? So in this way, waste cooking oil can fulfill a huge amount of requirement of biodiesel, right? The waste cooking oil is one of the main source and policy permits. Again, you can say this Food Safety and Standard Authority of India claims that India has the potential to recover 2.2 million tons, 2.2 million tons or 220 crore liters of used cooking oil for the production of biodiesel by the end 2022. Right. So biodiesel will be the main. This waste cooking oil will be the main source for biodiesel production in near future. But still, it is not fulfill the whole requirement. You see, now technique wise, I have told you that mechanical strength requires a lot of time and other things, right? Now, even this process intensification technique we have followed, that also improves the process in terms of time, money, energy, and other things. Remember that till now, conventionally, from all the seeds, first the oil is extracted, right? When we extract the oil, what happens? Due to compression process, huge amount of electricity is consumed. And almost we will see that the price of the oil becomes double due to the consumption of electricity. So there must be an in situ process. Means in situ means from the seeds directly we can extract the oil, and the reaction can take place simultaneously. So therefore, and even you see there are two requirements. Conventionally, you can say from any seed, whether edible or non-edible, extraction should be done through this PI techniques, so that if you do not want to convert into the oil, biodiesel, then you can say extract the oil. And if you want to convert to the biodiesel, then simultaneously you can have a transesterification reaction also. So this is the biodiesel production. This technique is called as in situ biodiesel, means directly from the seeds. So what we do, just seeds in a for a couple of minutes, we just crush it, grounded oil bearing seeds react with alcohol directly instead of reacting with pre-extracted oil. So after extraction, if you do it, then there is a two-step process. But if you just ground it or cut it into the different small pieces, in that case, what happens? The reaction or biodiesel production can take place simultaneously. In that case, the whole step becomes one single step extraction and transesterification process. So these seeds in a single step can be converted to the biodiesel. So that's why I also here the castor seeds. And in a single reaction, it can be converted to the castor oil itself. Of course, the cake and other things that can be utilized for other applications. The main advantage of this in situ biodiesel production is that it estimates the requirement of two separate processes, reduces process time, and reduces cost associated with oil extraction, reduces overall solvent requirements, and other things. So these things are very, very important. And this process, what happens, since the electricity cost will be drastically reduced, so in that case, the total overall cost of biodiesel production will be reduced. And plus, these techniques can be separately used for oil extraction also, and the yield achieved through these techniques are higher as compared to the mechanical stints. And further, there are many very special elements are there in the seeds, which due to compression process, what happens, the temperature increases, and those especially you can say proteins and other things, these elements will be spoiled. Just for comparison purpose, suppose conventional classification process, these are the number of steps one have to follow, whereas in the case of in situ classification process, the number of steps are reduced. In that case, seeds are there, and directly the in situ classification, and you can have downstream where you can collect the biodiesel. Here in this case, seeds, you have to crush it, then through the crushing, you can have a solvent, hexane extraction, through which you can extract the oil, and after the oil, you can have a classification reaction, and then the downstream operations are there. Obviously, number of steps in the case of conventional classification is higher as compared to in situ classification process. Now, I have talked about that extraction must be done in a very judicious way. The point is that once you crush the seeds, not by compressor process, just by a grinder, just can say breaking the cells only, and the particle of the seeds will be around say 1 mm. It will be there. So in that case, what happens? We can use this mechanism of solvent extraction method. When you use a solvent, suppose can say this crushed portion is there, then the point is that solvent we can use as a if you use alcohol, then they are the polar solvents. If you use this chloroform or hexane, in that case they are called as non-polar solvents. Non-polar solvents are less efficient as compared to the alcohol because they have the polarity. So the polar solvents are capable of penetrating the cytoplasm inside the seed itself, right? Cytoplasm, it can insert and through the cell membrane. The cell membrane, if you just break it, in that case, there are different steps through which we can bring out the oil through reactive extraction to the outside. How this is possible? There are different steps are there. First, the polar or non-polar solvent enters into the cytoplasm. That you see step one, this polar solvent will enter through this one. And in the second step, these polar solvents will make, you can say, it is linked to the wall proteins, right? It will extract the protein, and then this polar solvent just, I can say this, and take this oil with itself, and finally they will come out through this one. So this is the mechanism that 1 to 2. This is for the case of, you can say, polar solvents. Non-polar solvents also the same procedure one can follow, but it requires a longer time as compared to the polar solvents. The steps are same, but they are much faster in the case of polar solvents as compared to non-polar solvents. Right. So here the point is that polar solvents can break the lipid protein association by making a strong hydrogen bond with polar liquids. So that's why this combination is a very important one, and reactions and other things are also important. The solvent lipid complex thus formed moves towards the cell membrane due to the concentration difference. Here the gradient is the concentration difference. That is step 4. Through the step 4 it will come out. Why? Due to concentration difference, which is known as diffusion. The diffusion solvent lipids complex mixes with the static organic solid film formed around the cell wall and the bulk solid volume. Right. So the main thing that extraction mechanism remains unaffected for the conventional mechanical stirring process since it is dominated by the interaction of solvents and lipid molecules. So here this particular, you can say, extraction technique is important, and by using the PI techniques, a faster extraction of the oil is possible. So this lot of things, not only for the case of biodiesel production through transcription process, oil extraction also, and in our country, remember that still the conventional techniques are used. So this kind of oil extraction techniques are very, very useful, and ultrasound, microwave, and your the hydrodynamic cavitation techniques, one can use it instead of the mechanical stirring techniques. So now you see you see, I have started with the challenges. So both the challenges, technical challenges means PI techniques, if you apply it, it will be good. If you apply in situ technique, it is even better. If you can combine both the in situ as well as the hybrid reactor in which the two fields you are applying, so in that case, what happens? We have tried in our laboratory where in this, can say, typical ultrasound at the bottom, it is ultrasound. From the right hand side, it is microwave, right? And in between, this is slurry of in situ transcription process, right? Means we have seeds converted into the slurry form, and directly through the paste of the seeds, we can get the biodiesel. That is the main important one. And of course, this is from microwave. We have the two fields. One is the magnetic field, another is the electrical field. The two fields act on the liquid. From the bottom, there is ultrasound field is there. All the three fields act on this one. It will require a very less time and very efficient, right? And at the same time, in the microwave, what happens? You see there are formation of these are the random molecules, and they are converted to dipole plus minus. And there will be plus on that side and minus on that side. They are can say continuously. They are in a organized manner. They are just have a direction. Once it is organized at a molecular level, the point is that agitation will be there, and due to that agitation, what happens? The mixing goes very, very fast. So hybrid technique means we are applying ultrasound and microwave simultaneously. Ultrasound removes mass transfer barrier because mass transfer can say, sorry, here the can say ultrasound means uh, 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 this is the mass transfer is very good, and can say mass transfer barrier is not there, and microwave means removes heat transfer barrier, right? Okay. Heating is very good. So this is weak in mass transfer, this is weak in heat transfer. When you combine these two, its advantages are maximized and your disadvantages are minimized. That is the typical beauty of this can say combined way if you use it. I know very few papers or research papers are available uh, in this combined way. The reason is that you see where you will put the sample. If you put the sample in a metallic, then in front of microwave you cannot do it. If you use it a glass one, then the sample size will be reduced. So now it is a challenge that how to make a bigger one so that scaling can be possible. So these young faculty members and these young researchers, they can accept this challenge and provide a bigger one or a continuous way or develop some methodology through which this instrumentation portion or this particular reactor can be a combined reactor of microwave as well as ultrasound with the provision of variation in all these things. So that's why in this slide, can say combination of in situ means directly from seeds, and plus technique point of view, if you directly use hybrid reactor, it will be a great asset. Now, with a short time, it is difficult to manufacture. Of course, we have imported this particular furnace, this reactor, right? But again, the answer is that as an engineer, we have to give the answer for scalability. So therefore, in our laboratory at PDPU, Center for Biofuels and Biostudy Energy, we have developed a sequencer where instead of simultaneous application of ultrasound and microwave, we can have sequence. Means this is a storage tank. Through this one, it will go to this ultrasound. Through ultrasound, it will go to microwave, and microwave again it will come to that portion, right? So sequentially, if you go, even then it will give a very good performance. So sequential point of view, you can say size can say not an issue, and almost you can say you can get a very big amount of can say waste cooking oil or any raw feedstock is there, you can convert it into the biodiesel form. Ultrasound is here the main what is the main thing? Main thing is that we can effectively combine in sequential pattern with microwave irradiation, resulting in higher degree of intensification. The intensification is very high and the performance is very good. And the combination of typical ultrasound and microwave is very effective to eliminate the mass transfer barriers and heat transfer barriers. And mixing is very fast, and we have seen the results that um, biodiesel can be produced in a very less time. So the intense agitation helps in generating fine emulsion, which offer higher surface area for reaction and also for intense heating from the microwave. Right. So it is expected that such combinations can improve. You see, earlier combination was simultaneous. Now it is a sequential. So even sequential way, in a simple way, we can do the can say, form the combinations, and we can achieve a very high amount of yield. So this is a simple technique in our laboratory we are having. Overall, you can say that I will just explain that what is our overall strategy of doing the experiments. Our focus was waste cooking oil. Why? Because you see, we can use any oil, any edible, non-edible oil. But the point is that resource point of view, industry point of view, we have a large resource of waste cooking cotton oil, right? And this is one important source. Another important source is the resinolic castor oil. So castor oil, the point is that it is a very huge amount available in Gujarat as well as some other neighboring states also. So how we can utilize this big size of, can say, this uh, two sources available? So we have, even as an individual, it is not sufficient. As an individual, this is also not sufficient. So we have just produced a mixture of that one, and even in our experiments, we have considered that mixing is improves the property of the biodiesel also, right? So we have just considered that mixing proportion as a process parameter, and what can I say this mixing at what mixing conditions in what fraction this improvement in the property is there. So we have seen that 60% this uh, castor oil and 40% waste cooking oil in combination. If you do it, then you can produce a very good quality biodiesel also. Combination of these two, plus we have used the methanol. Now we are also trying for the ethanol also, because ethanol is a, I can say, the sustainable product, and since government is encouraging, so in the next time we'll just try with the ethanol also, because it is a higher order terms are there. So as compared to methanol, if you use ethanol, yield will be slightly reduced, but at the same time, properties will enhance. So once it is there, then we can have because we have two types of reactor, can say this catalyst. One is the potassium hydroxide, another is the calcium oxide. So with both the things, we have tried it, and yields are very, very good. So you can see the summary of the tables where different ratios of, you can say, molar ratio, catalyst, temperature, time, that is there. And in all the cases, around 90 plus, or some of the cases more than 95% yield we have achieved. So all the techniques which you have developed in the laboratory, that performance from industry point of view is very good. Only the couple of things, the issue is that how the scalability we can do it. But certainly, a mechanic combination of mechanical, chemical, and your electronics engineers. This, how we can design those systems in a bigger size. So in that case, what happens? We can achieve the target. We can use these devices for application of the industry. So it is this particular device is ultrasound. This is a typical microwave, and this one is a combination of these two. In sequential, we will use these two combinations. And another important point, I would just like to tell you that many of the people normally, you can say, they just take the things lightly. design of experiments. Nowadays, design of experiments has become a very as a developed art, and in the scientific way, one should do the experiments. So, normally, even I have seen the papers in the developed world, people perform a large number of experiments. So, what we can achieve in a very minimal number of experiments, if it is scientifically proved, then we should follow a procedure. There are many procedures among the Taguchi method is there, box beacon method is there, a central reference scheme method is there. So in that case, what happens? If the number of parameters are higher, then these techniques will give you a well-defined, I can say, runs, and those through those minimum runs, you can achieve the optimum conditions. And besides this one, at part load conditions, what are the variations one can achieve it. So these techniques should be based upon these techniques one should perform the experiments. Otherwise, what will happen? The time consumption will be very high. And plus, you can say it is not a wise decision that what we can achieve with a small number of experiments, we achieve it a large number of experimental runs. It will resources, it will have the effect on our resources also. I was talking about that can say ultrasound, microwave, etc. They are used for only for laboratory purpose. But this is a typical slide where I can say that scalability issue is resolved. Uh, Main thing is that there are because international companies are there, used in France and Hilcher in Germany. They are producing a very big size ultrasound and microwaves also. Microwave also used in the next slide. So, large scale props of ultrasound chamber per 200 ml, 40 liters per hour, and you can say from 1 liter per hour to 1000 liter per hour. Even that kind of ultrasounds are available. Up now, the main issue is that if you import it, it will be very expensive. So now it's a challenge for our industry that industry should come out and they should devise a mechanism where they can generate a bigger size of ultrasound. And once you design and manufacture that one, the same can be applied for the mass production. That is the only challenge that industries have to take a decision that how we can utilize the big size of ultrasound. Otherwise, the solution is available. And if you import it, then the price will be high and commercial viability will be difficult. Okay. So there are many types it is available. Plus, beside this one, there are multi-frequency ultrasound assisted extraction is there, divergent type multifunctional ultrasound machining equipments, multi-frequency non-contact ultrasound extraction machines are there. So all these machines, you can say now the issue is that now one cannot say that it is only small scale and is suitable only for laboratory. No, even bigger size one can design and you can apply it in your equipments. So in that case, what will happen? If you use the conventional bigger size techniques, hours are required. If you use this as a conventional technique for mass production purpose, in that case, in the minutes, the output will come. So until recently, couple of years back, people just produce a paper and then they will say that okay, scaling is a difficult in the case of ultrasound. No, no, it's not. Scaling, one can do it very fast. Microwave also, one can do the scaling very fast. Uh, in case of laboratory, almost you can say we have produced this one in situ reactive extraction of castor seeds for biodiesel. We have produced, and almost you can say, since it is a PI techniques and the latest techniques, so in a very good journal of impact factor 6 or 7, we have produced, and all our results are available there. And you can see that in that graph, within, you can say, in terms of seconds, you can say, as compared to other techniques, mechanical state, where other techniques at this stage it comes, whereas in the case of PI techniques, very less time you can achieve a very high amount of, you can say, extraction or percentage from the oil. And all your, can say, this kinematics is also important part of, I can say, oil extraction as well as biodiesel production. And these constants are very favorable for production. Modeling, if you do it from design of experiments, you will see that all the model points lies within plus minus 5%. In that case, what happens? It is a very rigorous and stable experimental results are there. That is also important. Now, quickly, I'll just summarize. I'll not go much details, but you can say that how this techniques, either you can say these techniques can directly applied for fuel production or as a pre-treatment also one can use it. Normally, suppose because algae is considered to be a very good fuel, and this algae, can say there are two things, there are two kinds of algae is there: a liquid wet mass or a solid mass the dry mass. If you use a dry mass, a lot of it is energy intensive. All the water you have to evaporate it, and then you can replace it. Instead of this one, if you use a wet algae, means in the liquid, if you are using this wet algae, if it passes through this restriction portion or a cavitation techniques, then what happens? This structure in intact cell, it will be broken like this, right? Or you can say generation of nuclei, expansion of nuclei, and collapse. Finally, it is collapse of the bubbles. So due to collapse of the bubble, what happens? It disrupts this algae cell. Once it disrupts, oil and other things can be extracted very easily. So time requirement around say 15 to 20 minutes. If the pre-treatment is given through this technique, then the point is that the cell is disrupted and oil extraction can be better in that case. This is a recent study done by ICT Bombay, but this is called performed that one, right? Here, the main issue is that when you use hydronic cavitation, even you can say as a pre-treatment, hydronic cavitation is promising, novel, energy efficient, and all other advantages are there. And main issue is that possible to implement hydronic cavitation for industrial scale microalgae cell disruption and further extraction of intermolecular compound is possible. So this is not a rocket science. Hydronic cavitation, we can use it in an energy efficient and scalable process of microalgae cell disruption. Because if you do not do it, in that case, again, it will require a lot of time. So this pre-treatment, if you do it for microalgae in a wet algae process, in that case, the final product will be improved. Now, that was can I say related with algae. Now, you see, Europe and other things recently in 2022, sorry, 2021, uh, Italy, lot of work has been going on. And we know that beer is an integral part of European society, European, US, and cold countries, it is there. Beer means the alcohol. So, alcohol point of view, they just carry beer, they have just this patented technology. And in the Italy, they have just constructed a plant where at atmospheric conditions, just you can say from the biomass or this seeds, edible oil seeds, they can convert into the alcohol itself. Again, in that case, they have to pass through restricted zone, and one can achieve that one. So here, the issue is that I can say the bioethanol can be produced through this one, and uh, technique is same, just like this hydronic cavitation, which I have explained. If you just look at this technique, which was, can say again, Italian researchers, they have done that one. And this whole process, if you just compare, this is a traditional line. First vertical line is traditional, this one and this one. Second line is hydrodynamic cavitation, where number of steps are less. You can see here it is a room temperature, then it is preheating, messing out, lautering, then messing out filtration, lautering, heating, and these are the processes, right? Whereas in that case, the messing only one process, because all these processes can come into that one, and with low temperatures. So due to that reason, what happens? Preheating and massive stages, around 12% of the energy consumption in that case energy can be saved, right? All other stages, for example, the messing out, filtration, and lautering stages, unknown possible compensated, they can be reduced, right? So main thing is that number of steps are reduced, uh, conditions are favorable. So due to that, what happens? Your last final product is also good with less energy consumption. You can do it. So that's why this beer technology is considered to be a good one to convert the biomass into alcohol. You can see that I think the next will be much better. Yeah. Here you can see that these are the conventional techniques. What happens? The boiling and high temperature boiling, then you have to cool it, and then extraction is done. So here, this is not complete extraction possible through a traditional brewing process. Whereas in the case of cavitation techniques, what happens? You can see the nature of this one. After hydrodynamic cavitation, what happens? The extraction is very, very good as compared to the conventional techniques. You see here, this is a typical the reactor is there, and through this reactor we can take the liquid, and through the pump it will pass through this nozzle or maybe venturi. So through this venturi it passes, and reaction takes place very fast. It will go like this continuously. In that case, inside reactor takes place, and finally you can get the product. Nozzle shape, dimension wise, it is there. Likewise, you can say design the nozzle like that. Of course, you see, whenever the product is there, for example, beer and other things, the foam test is there. The foam test with this cavitation technology and without cavitation technology, both are successfully formed. But the overall cost, energy consumption, and various other features are there in the case of hydrodynamic cavitation process. Now, suppose you see liquids are there, then it very easily you can mix it in the case of process integration techniques. But suppose biomass is there, then how you will do it? So in that case, again the technique is there. Inside the mesh, you can put a biomass, for example, this megacy and other things you can put it, and at the bottom portion the nozzle is there. So continuous liquid will flow through this one. Cavitation conditions are generated inside the nozzle, and due to this cavitation conditions, bubbles will go there, and this bubbles collapse takes place inside that particular portion. And this is you can say this megacy is there, that continuously through megacy the lignin and this cellulose, biocellulose, you can sorry, hemicellulose you can extract from that one. So in that case, in this manner, you can have continuous collection. That is also very successful, and results are quite okay. Cellulose and hemicellulose collection is important because ultimately through cellulose and hemicellulose you can convert it to the alcohol itself. Now, in the beginning, I have talked about that this biogas plant, that how you can improve the biogas plant also. You see, this is a conventional technology where we can just prepare the mixture and we can just collect that one. In between, if you retrofittingly, if you put it this one, where this is called as ultrasound converter, and this one is also called as this is a typical high speed impeller. It is there, and at the bottom you can generate the cavitation conditions. So whenever the mixture, suppose instead of going to the mixture directly, if the mixture passes through this portion, right, where outside this is ultrasound converter is there. So in that case, what happens? This lignin, which has a tendency to bind the cellulose and hemicellulose, this cellulose and hemicellulose, it will what happens? It will just, you can say, lignin will be broken away. Once it is broken away, what happens? What is the advantage? Inside, when you put it inside uh, substrate preparation tank itself, in that case, what happens? The bacteria will eat the biomass very fast. And if lignin is intact, in that case, it will take a long time. So that is the main advantage when it passes through this ultrasound waves. The lignin is broken and its strength with respect to cellulose and hemicellulose is reduced. Right? If you just look at the experimental data, you will see that there are two advantages. Biogas, we can say it is. We have this conventional one is this one, this ultrasound hydrodynamic cavitation. So here this is for the case of, you can say, this quality wise, how much is the percentage you can say methane produced, right? So this is there, not only you can say percentage wise it is there. So improved when you use the PI techniques, the percentage of this methanol as well it is improved. Whereas the total quantity it is there, quantity point of view is also it is increased. So here the main thing is that with less amount of time, more quantity and quality, all the three things has been improved if you use this ultrasound based converter or a disintegrated portion. This impeller, if you use it, you can convert the same, right? That's why the biogas plant play a very important role. And in our country, these techniques, if you insert it in the existing plant as a retrofitting or in new plants as an important essential component, so in that case, you can achieve very good results. Now, approach point of view challenges, you see, nowadays, you cannot say that give me the oil and I will produce it as a fuel. When from farmer's point of view, from researcher's point of view, suppose 1 kg of castor plant, this is applicable for all kind of plants. Any plant of this which produced, you can say seeds, stem or leaves. So castor seeds, this is the ratio. Now you say that I will convert from seeds to biodiesel, and what about do I will not tackle about this one? No. As a biorefinery project, biorefinery concept, each and everything is important, right? Suppose I have seeds, I can extract the oil, then I can classification, I can convert to the biodiesel. If seed cake is there, I cannot say that seed cake I cannot utilize it. Seed cake can be utilized for as a pre-treatment, and then through pre-treatment and as a process, it it can be converted to ethanol. Or anaerobic digestion, it can produce methane, right? The point is that nothing is waste in the nature. Both the solutions we have to do. We are working in that area, that how we can produce the solutions. Similarly, STEM is there. So through pre-treatment process, we can have anaerobic digestion, and essentially in that case we can get the methanol or ethanol. For leaves, we can have anaerobic digestion, where methanol we can get it, and for pre-treatment process we can get the ethanol. The point is that nothing is waste. You see, whatever the input we are supplying, all should be converted into the fuel. The right hand side wise, you can see the fraction of the fuels, and left hand side you can see that the total there's an input or a fraction of the Castor's plant it is there. So we cannot say that any other component is a waste one. Nothing like waste. Input it is there, and our biorefinery concept point of view, each input we should convert it. So this is a very important concept, and based upon this one, in our country also in near future, this biorefinery concept, this Reliance is coming in a big way. In Andhra also, one company is coming for as a biorefinery that whatever the input, this biomass and seeds are there, convert all the things into different products. I'll not go much in because hydrogen is entirely different thing. Electrolytic process we know very well, right? Electrolytic process we can produce hydrogen, and it is a well-established technology. But if this whole process is done below the ultrasound is there, if you supply the ultrasound waves, then what will happen? This whole 10 to 20% of the reaction will be faster. So whatever you are getting hydrogen, 20% more hydrogen if you are getting, the researcher will never mind, because you can say you can get more hydrogen from this process. So this is called as sono hydrogen. Sono means due to sound waves we can produce hydrogen. So Denser and his group, known as a very well-known group from Denser from Canada, and they have developed this technique that okay, whatever the electrolytic process is there, using this ultrasound below this actuator is there, and through that ultrasound waves are there. And that this ions transfer will be very fast, and due to that one, the hydrogen production will be very fast. This also we can produce it. It is there. Besides this one, other important part is that we talk about the farmer's income, right? Through biodiesel also, a small scale plant. Normally, people in the Europe they consider a big size, always convert into an automatic and bigger size. But in our country, this is not good. Always go for a smaller one, mini scale, startup, other things, so that farmer can himself can convert the seeds, using the seeds, it can convert into the biodiesel and he can use it itself. It should not be dependent on the diesel produced by the government itself. In that case, his income will increase. And besides this one, other important aspects are that there are many cash crops are there. In the proper way, if the cash crops, if we develop, then those cash crops, they can utilize it through this ultrasound and microwave, and they can get the nutrients. Sometimes these nutrients, a couple of nutrients, they are having a price of 12,000, 1,200 or 12,000 rupees per kg, right? So that is the beauty of that one. And in a proper selection of cash crop, you can convert by using the ultrasound. You can use this. In that case, what happens? The bubbles are formed. Bubbles will break the outer boundary, and due to outer boundary, that it will free the nutrients. It will come out, and those nutrients can be collected. This is this a lot of work is required in the case of horticulture, and even your mechanical engineers or this ultrasound engineers can play important role to develop the technologies suitable for the case of farmers. Otherwise, just by growing, farmers' income will not increase. How the technology can be integral part of farmers, and remember that whatever the technology for agriculture we have given to a farmer is capable enough, and he's producing, and that's why the production has increased. But now for next level, only for production it is not possible. The technology where this value addition can be possible. I can give you an examples. For example, the potato price is very less, but the moment potato is converted into chips, its value addition is tremendous. 10 times the cost will increase. This kind of things we have to think in this manner, so that how the farmers' income through these PI techniques we can increase. That's why the extraction techniques in the Europe they have developed this sono-soxylate. Soxylate is a very important one. Soxylate conversion techniques where through boiling one can use it. So with boiling as well as ultrasound combined, if you do it, in that case at low temperature pressure conditions, you can say extraction is possible. So these are the combination of ultrasound and SOxLess technique. SOxLess already existing. Ultrasound, if you just combine it, in that case, the technique will be very, very fast. So the diagram is self-explanatory. One can say follow this one in a very, you can say, simple way. Extraction techniques can be there. So we have a huge amount of products in our country where, I can say this, pharmaceuticals and other things, they are using a conventional technology, which should be replaced by these modern technology. This is a typical examples of, you can say, microwave equipment. So earlier, you can see that at home microwaves, they are smaller one, but even big size microwaves are available. And those microwaves, what happens? These microwave frequencies, what happens? This dipole moments are generated in a particular direction, right? So this is a typical haphazard way, and whenever the field is applied, it will be a typical plus minus minus plus. It will be there. So continuous variation of plus minus minus plus. What happens? The mixing takes place very fast. Extraction of the oil is very fast, and why this has a wide range of applications as compared to the conventional one. So microwave assisted extraction of bioactive compounds is a very, very important one. And you can extract the can say oil from the seeds, or from cash crops also you can extract the seeds. Even you can say microwaves are available 75 kgs, and if your operation becomes continuous operation, then it will become very, very fast. So I will not go in much details. You see, bioactive compounds you can extract through these techniques. So industrial interest of naturally occurring bioactive compounds are on continuous rise, and to growing demand, what happens? This methods can be a viable option. The method which I have discussed. So these phenolic compounds are there, phenolic acids, flavonoids, all these things are there. So I will not go through the details of that one, but the concept is same. Extraction through this ultrasound and microwave, very easily you can extract it. So therefore, I have started with the fuel, but non-fuel applications are also important, which people have not considered, not thought about that one. So from that point of view, a small contribution will play a very important role in our economy. Of course, you can say this is bioactive compounds, then oil crops, I already discussed. So this SOxLEX plus in combination with this ultrasound, one can use it. So you can see that fruit seeds, nuts, almonds, papaya seeds, rapeseed, sunflower, soybean, flax, in all your edible oils, how to extract that one, that is also important. So these techniques are not suitable for only for, say, for non-edible oils, because if it is suitable for non-edible oils, the same can also be suitable for the case of edible oil crops. And if these techniques are available, I can assure you that prices of the oils due to technology can be reduced 10 to 20%. So this edible oil price is also very high, even 100 plus it is going on. So that's why the new techniques are required to extract the oil from the seeds itself. Beside this one, it is having cosmetics, soaps, perfumes, food flavors, various applications are there. Right? So main issue is that US assisted ultra extraction of oil from rapeseed, rapeseed or any other oil has a better efficiency than the conventional maceration. Maceration conventionally extracted from by compression process. Even if you due to that one, what happens? A huge amount of electricity is consumed, and that's why the price of the oil increases. So this process of ultrasound extraction is much easier. Microwave you can use it, and through that one, the time requirement is less, less energy is required. So that's point of view, you can say that's a very, very important one. Of course, lipid wise, it's always important because you have the free fatty acid component, you can remove it, and then that can be converted into the biodiesel from other parts. So lipid component, free fatty acids, normally remember that free fatty acids, if you just decompose them, then they can be used as a this phase change material, PCM. So they have different characteristics, and they can also be applied for PCM. And PCM is nowadays very, very important because uh, renewable energy is intermittent in nature, and due to that one, the can say the storage systems will play an important role. And in that case, phase change material will be very, very vital for designing of this storage systems. Okay, so we can say that even ultrasound as well as hydrodynamic cavitation, they demonstrated a high lipid extraction efficiency from dry microalgae, which is vital for biodiesel production. So lipids means lipid one application is that one, and nowadays another application will be for storage systems. So fuel you can prepare it, at the same time you can have a storage system also important. Now, this is a very important slide given by an Italian expert. And I'm not saying that it is a breakthrough, technological breakthrough. It is the best experts. They are saying that hydrodynamic cavitation assisted production of fruits and vegetables, beverage, and including beers. It is a really a boost up in the sustainable technology. So I have talked about the fuel, but besides this one, agriculture, this will play a very important role. For example, so he is saying that greater than 50% saving in core processing time and energy consumption, greater than 25% cost saving in saving is there, reduction and better use of waste systems are there. It will boost the farmer's income. The point is that when you talk about the energy and other things, ultimately it is a human being. And how we can boost the farmer's income, that is a very, very important one. So this will enhance the agriculture entrepreneurship, government assisted tax, this increases prosperity to low input organic farming. So various wide range of agricultural issues are there, which includes the energy issues, environmental issues. For example, say this is GHG, almost can say this is drastic improvement in the resource using efficiency. So all these aspects are important when we talk about the process identification, and particularly hydrodynamic cavitation techniques. They can play a very, very important role in the development of sustainable development of technology, including the fuel as well as the non-fuel applications. Right. So almost I have seen that last 2 years a huge number of papers are coming based upon the cavitation technology. So still it is a developing stage, and it is not a rocket science. So quickly, and plus the point is that people say that it is a limitation of from industry point of view, but for our country point of view, small is beautiful. So at a small independent plants can be installed, integrated with the agriculture itself, where you can generate the fuel at the same time. You can use it for non-fuel applications, means for sustainable extraction of the oil and other things one can use that. Okay. We are at present, I'll just introduce you that based upon our techniques, the cell energy, and they have given us a project for biodiesel, where we just start up with the typical plant as a waste cooking oil plus non-edible oil mixture. We'll just can install a 100-liter plant, and then we'll use the mixture in such a way that it will improve the properties of biodiesel. Besides this one, we have all in the future we will like to work with biolubricants. Lubrication is lubrication, again the conventional lubrication oil is the pollutant. So if you use biolubricants and through biodiesel route, again the possibility exists. There are many at present at high temperature pressure this lubricants are produced. If you follow the biodiesel route, in that case, in a single two-stage process, we can produce a biolubricant in a proper way. Right? So this TEMPTE process, the trimethyl propane triester method, recently developed, and it can be converted. This Saudi Arabia, in a big way, it want to convert the waste cooking oil into this biolubricant, because a big business in the world is it will grow in a big business in the world for biolubricant, because everybody want to substitute our conventional lubricants by biolubricants. So this is typically not a saturated fuel. Biodiesel may be saturated, but through biodiesel route, how to get the biolubricant, that's important one. Besides this one, I have not introduced here is that conversion of this kerosene oil or biojet oil, which is used in aeroplanes and other things. Because when this conventional biojet oil, the jet oil consumed in the aeroplane, and 20 liters per second, huge amount of CO2 emission is there. If you use produced through biodiesel, this jet oil, and if you mix it with the emissions can be reduced. So that's why in our country, this Dehradun, CSS are they are working in that area. Now we are also introducing that how to produce this aeroplane fuel through this one. We can try. So biodiesel route, we can get the biolubricants as well as biojet oil also. And mark my words, it is a huge number of applications, and this is the unsaturated area, and this is an opportunity to grab this value within the time. Of course, this ultrasound assisted. Now you see everybody is talking about the battery. Now battery wise, the point is that suppose battery wise what happens, large number of batteries are there, they have life for 5 years. After 5 years, huge number of batteries will be just like a wastage. How to do the recycling process? So that particular technique is known as this biobattery, this hydrometallurgy. So through this hydrometallurgy at low temperature pressure, how the separation of this bleaching process, you can separate lithium, cobalt, and other things. So this ultrasound techniques is also important. At present, the boiling and very high temperature pressure conditions are required for can say recycling purpose. So these techniques which I have explained, the same technique can also be applicable here for separation of these elements, and therefore this particular technique is known as this hydrometallurgy, which is a very simple one, and this is again an unexplored area where this recycling can be possible. Yeah, that is a flow sheet. I've explained all that one. Uh, One more couple of, you can say, applications. I will just tell you that even this petroleum also, this tactic can be used. You see, drill and other things, what happens? They are very expensive. When a drilling takes place, it is very expensive because proper lubrication is required. And if you prepare the lubrication, then what happens? There is always the knots and other things are there. They are not proper. So what happens through this technique? What happens? You can say, if you produce a typical lubricant, in that case, viscosity is a very important element. The viscosity is drastically reduced in the lubricant so that it can be used for drilling applications. Besides this one, what happens? Whatever the crude oil, if you get it from the well in the jungles and forest, it is a viscosity is very high. So if you use a bioethanol or these elements into that mixture, what will happen? We can reduce drastically the crude oil viscosity, and then that oil can be transported to the city or in the industry where you can just can say again recover the, this particular fuel which you added. So in that case, what happens due to hydrogen donor, the crude oil property changes, viscosity drastically reduces. You can see that here heavy oil 1.5. If you after cavitation and mixture, it is 183 only. API gravity, slight we have to improve it. So it is increased. So due to this change in properties, what happens? Even these techniques are suitable for conventional fuel also. They improve the conventional fuel properties and transportation. They can improve it. So I have just touched the iceberg. Huge number of applications are there in conventional as well as unconventional. The challenges I have talked about, technical challenges as well as the policy challenges. Policy challenges point of view, we have to grow the feedstock in the proper way without disturbing our food cycle. So then only we can rise to the occasion, right? So now I can say, let me summarize the whole thing. As a researcher, we should not be afraid of that. So suppose I am a mechanical engineer. I've never read about this biotechnology, other things. The combination of mechanical with biotechnology, because you see, hydrodynamic cavitation pumps and other things, biotechnology person do not know. A biotechnology person knows the chemical these reactions, biotechnology reactions. So any research, if you want to do, is so nowadays the interdisciplinary research is a very important one. For me, my chemical people are working that one. My chemical faculty is working. So all these things, biotechnology, extraction, food, supply chain, pre-treatment, water treatment, team of different disciplines will have to play a role. So now the era is gone where conventional people can work in a typical area. Another important point is that hydrodynamic cavitation is a typical technological breakthrough because in that case it can be used for fuel, non-fuels, and other things. It's not rocket science, and even scalability point of view, it's a very good one, right? So after COVID era, what happens? You see, petrol tax is increasing, biodiesel tax is increasing. So in that case, what happens? We can go a typical hydrodynamic cavitation techniques. We can apply it for startup purpose in different applications, and there is opportunity for, like I said, this market as well as your can say job opportunities are there. So in a simple way, through startups, we can start it using the hydrodynamic cavitation techniques. They can play a very important role in near future. That's why I've used that PI techniques and SC techniques. They have enormous potential for new job opportunities, which is very important in developing world like India. And there's a need to integrate PI techniques in laboratory courses. We have to teach the course. Unfortunately, these techniques are not taught in the classes. The students is not aware of these techniques. So at least this should be a part of our engineering curriculum, irrespective of any branch. With this one, these are the recent differences. Almost all differences are from 2021. It is there. So these are the recently developed. And this is a brief idea regarding the facilities we have developed in our biofuel laboratories, Center for Biofuels and Biotechnology. We have developed the reactors, ultrasound, microwave, hybrid reactors, sequence reactors. We have developed techniques. We have developed is HC cavitation reactor, power socket reactors. We have developed. Then catalyst-free supercritical autoclave we have developed. We have feedstocks basically focus on waste cooking oil and castor oil. We have done that one, and in situ transcription process we have done out. Now we want to enter into the biolubricants and your jet oil also. The near future, let us hope that in a different way we can go for that one. So this is facility which is there, and some of you, if you want to, can say interested in that, you can do the collaboration or you can visit this laboratory and get some benefits, right? So with this one, I'm again thankful to the organizers who can say with their can say they have given me the opportunity and two continuous hours. I know that it's very difficult once you are at a listening mode, but really I appreciate your patience for listening. And once again, thank you very much to Dr. Bharatbhai and his team and the what can I say the entire administrative team of Modasa Engineering College who has given me this opportunity. And once again, thank you all and wish you all the best for this particular FDP program. Thank you very much. This is all from my side.